the diagram, then the resultant field will be the field inside the sphere with cavity. So where the find the E inside the cavity is asking magnitude as well as direction. In gravitation chapter, we have discussed, if you can remember. Okay, let me take the same diagrams again. They're going to help me. Not needed. I'll draw a fresh diagram. Yeah. Let's get into the discussion. So here, this is the sphere without cavity. Next, we'll go for again a cavity. Where is the point? The point will lie inside. The point will lie inside. So where is the point? Let me indicate it. So the point is somewhere here. I want the field strength at point P. So those points I'm going to indicate. So this sphere, the point P will be here. And this will be the sphere. So this will be C1. This is the radius R. This will be of minus negative density, C2. This is C1. This is the point P. Yeah, no. Get in this one. So what is this sphere? Okay, negative charge density. So this is the sphere without cavity. This is like a sphere with negative charge density. When I keep both here, when I go and place it here, then what do we get? We get here sphere with cavity, and that is what here. No, don't bother anything. Just look at here. What will be the field? What should be the electric field here? How the direction of electric field? These arrows are very important. Please make this one. The electric field vector should be in this direction. Called E1. The point P is here, no? So what is the electric field? Electric field should be radially outward. And what is E1? Do we know E1? E1 should be equal to rho R by 3 epsilon naught. I want the magnitude. There's a magnitude rho R by 3 epsilon naught. So in terms of vector form, it will be C1 P bar by 3 epsilon naught. Please try to understand in the vector form. In the magnitude, how much will be rho R? This will become small r. So unit vector. So magnitude into unit vector should be equal to vector. So C1 P bar, I'll write it. Similarly for this, how the electric field strength should be towards, why towards? Why it should be towards? Because a negatively charged one, no? What should be the E2? E2 bar should be equal to rho C2 P bar by 3 epsilon. Already don't put negative sign here. Already that negative sign we have taken care by assuming the electric field. Able to understand? So I think that the vector thing, if you can understand this, this will be very easier. So from where you wrote it, this, what is this equation? Go back here. What is the electric field inside the uniformly charged sphere? Rho R by 3 epsilon naught. If they give density, if they give charge, it should be K cube by small r by r cube. I told you, I made alert, no, when they give charge, use this formula. When they give density, use this formula. Fine. For a positive charge, it should be radially outward. For negative charge, it should be radially inward. Agreed, all of you? Okay, this is what I'm applying here. Nothing big. I think this is what we are discussing. Yeah, there's a page. Now, shall we take the vector sum of these two? The vector sum of these two will give the resultant field. So that E bar, I'll show it here. directly from here, this is E bar. And next, what we have is, this is E2 bar. This is what? E1 bar, this E2 bar. The resultant field, how it will be? The resultant field will be some other color needed, black color. The resultant field should be in this direction. So what is net E bar? E bar should be equal to E1 bar plus E2 bar. Okay, I'll show by the mathematics also. Rho C1P by 3 epsilon naught rho 3 epsilon naught you take outside. So C1P bar plus C2P bar. You take help of just simple. Okay, this is C1, this is P, this is C2. Triangle of vector addition. Tell me, like this vector, this will be a resultant vector, no? And what is the resultant vector? C1P bar plus C2P bar minus C1 C2 bar equals 0. If you move from tail to head, positive, tail to head, positive. From head to tail should be negative. So therefore, what is C1P bar plus C2P bar? Should be equal to C1 C2 bar. So what is C1 C2? The distance between the center of sphere and center of cavity. Directly in the vector form is what I brought it. And how much C1 C2? We know it is equal to R by 2. Look at now C1 C2. Are they constant as it is? So what happened? This field will be uniform. So everywhere inside the cavity, what is the electric field? Will be uniform. And how much magnitude? Rho by 3 epsilon naught, the distance between center of sphere to center of cavity. Able to get this? This will be uniform. So now we'll go for diagram. Just make observation. I'll explain further. If you have any doubts, you can clarify now only. I'll give one more better diagram. Now, if you have a cavity, why it is not selecting? So cavity need not be like this. Cavity can be of in any shape, any spherical shape, and wherever it may be, that one. So this is the cavity, no? Let me bring the cavity. I'll show the field. That field has to be shown, no? Yeah. Okay, this one. Next for the radius. This is radius R. So this is the point C1, C2. How the field will be? We have to plot the direction of field. The direction of field will be along C1, C2. So here is what I'm showing it. Why that horizontal lines I'm drawing? And that to uniform field I'm showing it. Getting the idea? So this will be the cavity. There's a sphere with cavity. And how it will be along, how the E bar will be along line joining the cavity. So here uniform field directed along line joining from the center of sphere to center of cavity. The field will be uniform. I'll show complete description what all we discussed. Anybody having doubts, you can clarify related to this. The field here will be along line joining center of sphere to center of cavity. Means, sir, is it cavity should be in contact? No, even the cavity of this shape also no problem. It will be the distance from the center of the sphere to center of cavity. The magnitude. Okay, now I can ask you so many problems here. No, I'll take a charge particle, I'll project it, and let the effect of gravity present. So then what happened to charge particle is going to discuss projectile motion. Here the weight mg and electrostatic field will act. Agreed. I'll suspend a pendulum here. It's going to oscillate SHM. The weight mg and this horizontal electric field. So it's be there in equilibrium. At this point, it will oscillate. So we have so many things inside this cavity. Now I'll bring some mechanics problems. I'll release a charge particle here. With what speed it will strike the other end of cavity. If I release a test charge here, I think it will expend force towards right and it will accelerate and it will strike this point. Can we calculate the speed? As we know electric field, we know acceleration, and we know the distance, radius of cavities r. So like a diameter is 2r. So, sorry, diameter is r. Uniform accelerated motion problem you can apply. So all kinematics problems, mechanics problems I can introduce here because the field is uniform. Agreed? Okay, no, few more that conditions are there related to this. Then I'll discuss that. Then we'll go for a break. Huh? So sometimes the cavity can be so cavities can be very small cavities, not something big, and I'll bring it somewhere here. You see that they're not in. It was a little bit different compared to other one. So this is the radius. Okay, radius of cavity is something here. The radius of this, let it be A. Radius of this, let it be B. This is again, it's there in Edo. This problem is there in Edo. If we have like this here, look at no, that little bit some change I made. So there's a cavity. I want the field strength inside the cavity. Look at this. Earlier, this part of the cavity was stretching here, no? So what is this? This is a sphere with cavity. So here, let me call this is C1, C2. Again, the formula is same. You need not to bother. So what we do is like, if they give question of this kind, so what to do now? I'll show the vector method the way this one. So I'll erase all these things. Where gone? I'll remove this better. I'll draw the other one. This not getting. And the same diagram. Okay, now this is the cavity. Can we use the same formula or we have to derive something? So it is not in somewhere here. It consists there is a gap is also there. I have brought also some gap. So again, the vector diagram, what it says, the vector diagram. Okay, these are the center. So this is the point C1, C2. Somewhere let me choose at point P. Then field strength at point P due to sphere without cavity, it will be directed here. As negative charge density. So therefore, I'm going to bring another vector like this. So the resultant vector, how it should be from C1 to C2. I think the problem solved. Hope if you can remember. So what is this? This is E1, this is E2, and this is E bar, the resultant vector. What is E1 bar? Okay, what is E bar? E bar should be equal to, I'll push it to corner so we can write equations. Yeah. What is E bar? E bar should be equal to E1 bar plus E2 bar. What is E1 bar? Rho C1 P bar, shall we write? Should be equal to C1 P bar plus what about E2 bar? E2 bar should be equal to rho P C2 bar by 3 epsilon naught. Rho by 3 epsilon naught. C1 P bar plus PC2 bar. Okay, what is PC2 bar? Now, C1 P bar plus PC2 bar should be called C1 C2 bar. Shall we write anything further? So this will be A bar, no? And this will be B bar, A bar minus B bar. Very simple. Or let it be like this. So C1, C2 bar, I'll calculate from the diagram.
Sir, one doubt, sir.
Uh,
Sir, E2 is having negative charge density, so why are we not writing PC2 minus rho? Why we are not writing, sir?
my dear, for positive charge, the field should be radially outward. For negative charge, the field should be radially inward. The negative charge already I consider no by indicating direction.
Yes, sir.
Okay.
Yes,
Huh?
sir. Yes, sir.
Fine. Already the E2, the here negative charges that I consider. This is resultant field. This is within cavity. I'm showing it.
Yes, sir.
Positive charge should be radially outward. Negative charge should be radially inward. So we'll get this one. So now whether this cavity should touch this irrespective, no, it can be somewhere here. It can be somewhere wherever it may be. Okay. Now, instead of cavity, if I bring this 2 row, what changes you're going to make it? Instead of cavity, let it be sphere of density 2 row. I think we have to go back to the basics here. So what we have to do, if this is a density of 2 row means, what does it mean? Row plus row it is. Because when you take plus row, it will become 2 row. Instead of here, if there's a density of this particular green, instead of cavity, let this region have a density 2 row. I can ask you like that also. In that case, what you're going to do? So this is having density row. This is 2 row means here this will become plus row. Am I right? Then plus row will become 2 row. Then in this case, what happens? The field will be E2 outward, not radial outward. Agree this? Oh, here vector diagram, negative charge. So some correction I'll make it. Here I didn't write properly. P2C, then okay. P2C bar it is. Symbols I didn't write properly. Yeah. Okay, positive charge also they may bring. I just made some changes that P2C bar, it should be there. Here, look at this one. PC2 bar. I made changes. PC2 bar. Then okay. The vector addition. Take help of the vector addition. So cavity curve problem comes. So it's better to take help of the formula. If they give density, use this particular formula.